Hello, I'm Idan Kenter from Dell Technologies. In this demo, I'll be showcasing Red Hat OpenShift Virtualization VM protection using Dell PowerProtect Data Manager, or Data Manager for short. Data Manager version 1919 protects OpenShift Virtualization VMs in addition to the proven container data protection we've had for quite some time. It supports OpenShift Virtualization across all supported OpenShift releases and features support for block and file system volume modes. It also features the ability to restore on a per VM basis, along with orchestration capabilities such as protection of VM spec, data, including data volumes and PVCs, MAC address provisioning, and the option to restore to the original or an alternate namespace, including power on the recovered VM. Now let's head over to the OpenShift console to have a look at our production VM. This is our production CentOS VM on the CentOS VM Prod 1 namespace. Let's have a look at the VM configuration. The VM has a VNIC on an external network and a SSH key configured. Additionally, as you can see, the VM has a block access mode disk provided by Dell PowerStore using a storage class called PowerStore Block. With that, let's protect this VM by bringing up the Data Manager UI. First, let's look at the registered asset sources. We have our OpenShift cluster registered as an asset source. It's worth mentioning that if you are already using Data Manager to protect your OpenShift container-based workloads, you don't need to register anything new to protect your VMs. Just ensure that you're using Data Manager 1919 or later. Now let's go to the protection policies and add a policy to protect our CentOS VM. We'll call it CentOS 9 VM1. Find the namespace in the list of discovered Kubernetes namespaces. Let's configure a primary backup stage. Pick our data domain array, configure a schedule of an hourly backup with retention of 14 days, and off we go. Here's the protection policy we've just created. Now, before we back up our VM, let's have a look at the prod VM and its data through the CLI. First, let's list the VM with the namespaces using the ocget-vm command. Have a look at the VM configuration by specifying ocget-vm with -o YAML for YAML output of the VM spec. Now let's connect to the VM. We'll do that using virtctl and this SSH key we specified in the VM configuration. Cool, we've successfully SSH'd to our production VM. Our CentOS VM is PostgreSQL. Let's have a look at our production database and the data it contains. As you can see, the database contains a table with employee details. Let's return to the Data Manager UI and perform an ad hoc backup of the namespace. We'll monitor the progress of the backup process. I'll fast forward through this part, but note the steps. Data Manager first performs metadata backup, issues a CSI snapshot of the PVCs, and then backs up the snapshot of the PVCs and data volumes. Finally, Data Manager automatically deletes the CSI snapshots and creates the copy in the system. Let's switch back to our production Linux VM. We're witnessing human error in real time as the production database was accidentally deleted. No worries, Data Manager to the rescue. Let's navigate to the Data Manager UI and restore our VM to an alternate namespace. We'll go to the resource section and locate our production namespace asset under the Kubernetes asset type. We'll pick our latest copy. The full list of copies can be seen by clicking Change Copy. Data Manager allows you to restore to the original or an alternate cluster. In this case, we want the application to be tested on the original cluster. Data Manager features the ability to restore on a per VM basis, so we'll choose the option of restoring Kubernetes virtual machines. Data Manager also features the ability to restore back to the original namespace or a different namespace, existing or new. We'll go with the option of creating a new namespace and assign an original name to it, CentOS 9 VM1-restore. In this step, we can select which VMs to restore. So we will pick our CentOS 9 VM. We also have the option of changing the storage class to one that is compatible with the target cluster. As mentioned earlier, we can also power on the recovered VM. Finally, execute the restore. Great, the restore process was initiated. Let's monitor its progress. Awesome, the restore is now complete. Let's shift gears and open the OpenShift console to see the recovered VM in the namespace we just specified. Next, let's SSH to our Linux management host. To see the recovered VM, we'll run ocget VM with the new namespace created by the restore process. That will be CentOS 9 VM1 restore. Now, we'll SSH to the recovered VM using virtctl. Note the data manager restore also recovered the SSH configuration. And we're in the VM. We'll connect to the production database, list tables, and finally query the employee table. As you can see, the data is there. We're all set. And there you have it. Thanks for watching, and see you in the next demo.